I'm Delphine Dean, and I know nanotechnology. Nanotechnology is a field that refers to making, characterizing, and using materials that are on the length scale of nanometers. So if you look at your hair, the cross-section of your hair is about 50 microns. So a nanometer is actually, it's much, much smaller than that. It's about the same size difference as if you look at the whole Earth and you think about a soccer ball. That's the length scales we're talking about. So they're very, very small, but they can do a lot of things. You may have seen nanotechnology and nanoparticles in different products. If you use sunscreen and it's very white and it has zinc oxide, those are nanoparticles, and they work because the particles will stick on the outside of your skin and block the sun from coming into your cells. There's more nanoparticles that you may find in the news, the big one being carbon nanotubes. And now you can buy golf clubs with carbon fibers and tennis rackets with carbon fibers. And the way carbon nanotubes are set up is that they're very, very thin, but they can be very, very long, and they're very, very strong. So if we were able to make a really, really, really long carbon nanotube, there's all sorts of applications we can do, but unfortunately it's very hard to make these materials at very, very long scales. But if you put them in a tennis racket, it will make your tennis racket sturdier. What we're looking at in our lab is how these very small engineered materials will interact with your cells in your body. This is a big area of research. In particular, there's a lot of people trying to use these particles to make new cancer drugs or imaging agents, because you can make a little particle that has a drug. It also has a imaging agent, and then these particles will stick only to the cancer cells and then only kill the cancer. But one issue is that they're very new materials, and so we're trying to understand how these affect other cells in the body besides the ones they're meant to target. So one of the studies we have going on is looking at how different particles made of gold, so same thing as your jewelry, but very small. So you think it might be expensive, but since they're very, very small, it's not very much gold, and how those affect your cells. So gold nanoparticles are already approved. You could go and get a therapy where if someone injects them in your body, but they're not very well understood. And so what we found is that actually, if you look at vascular cells, you can have some particles that will make the cells stiffer and some that will make the cells softer. So you could actually maybe use some of these for therapies depending on what disease you have. Also, it's good to know that that happens so that if you're going to inject them to do something else, they don't mess up the rest of your cardiovascular system.